Hydrogen is poised to change the way our world uses power. As a global leader in electrolyzer technology, Cummins is all in on hydrogen. Here's why. The energy sector is at a crossroads as we face tough challenges around how to reduce emissions from difficult to decarbonize sectors. Hydrogen has the potential to decarbonize many carbon-intensive industries, such as transportation, manufacturing, and agriculture. It offers reliable mobility, backup, and off-grid power options, as well as supports renewable energy deployment and integration. Green hydrogen is the highest standard for hydrogen power. Hydrogen is fully green when it has no associated carbon emissions. In the transportation sector, this is referred to as being green from well to wheel. Green hydrogen can be generated by an electrolyzer, powered by renewable power such as wind, solar, or hydroelectric. Plus, hydrogen has zero carbon emissions at point of use. Its only emission is pure water vapor. Hydrogen can be used as fuel in hydrogen fuel cell applications like buses, trucks, and trains. It can also be directly injected into gas grids and/or used in industrial applications for fuel production or in the production of green chemicals such as methanol and ammonia. And it's also a highly efficient way to store and transport power. Hydrogen is more than an element. It's a promising solution to one of the greatest challenges in the renewable energy sector: storing renewable energy when it is not in immediate demand. Electrolyzers enable the storage of excess energy from wind, solar, hydro, or other renewable power sources, energy that might otherwise be sold off to the market at a financial loss or not used at all. Instead, this renewable energy can power electrolyzers that produce green hydrogen. Hydrogen fuel can be stored for long periods of time and in quantities only limited by the size of storage facilities. Hydrogen can be easily stored and shipped in tanks and pipelines. That means that areas without ample or reliable renewable energy sources, like wind or solar, can still access carbon-free energy. Hydrogen makes greener power more accessible across the world. Global emissions targets demand new solutions, and we believe hydrogen's unique potential will be a key factor in building a carbon-neutral future for everyone. In January 2021, Air Liquide inaugurated the largest Proton Exchange Membrane electrolyzer project in the world in Becancour, Quebec, using cutting-edge electrolyzer technology supplied by Cummins. This PEM hydrogen electrolysis plant is capable of producing 3,000 tons of hydrogen annually. With the commissioning of this electrolyzer system, Air Liquide facilities in Quebec have increased their hydrogen production capacity by 50%, allowing them to respond to the growing demand for low-carbon hydrogen in the North American market, whether for industrial or mobility purposes. The Cummins PEM electrolyzer, called HyLYZER, is the workhorse and centerpiece of the project. Powered by electricity from renewable energy sources, the system will produce hydrogen that is 99% green, helping to reaffirm Air Liquide's goal to produce low-carbon or renewable hydrogen for mobility needs by 2030. It is a great illustration of both Air Liquide's and Cummins' commitment to generalize the use of hydrogen as a clean energy vector, and is a key milestone along the path towards a low-carbon society. The installation features industry-leading technology. 4 compact pressurized HyLYZER electrolyzer skids were fitted inside an existing building. The systems are modular and scalable, perfect for large-scale utility applications. Cummins HyLYZER units have one of the highest power densities and the smallest plant footprint in the industry. The electrolyzers are powered by the region's electrical grid, which is largely supplied by hydroelectric power. That means the hydrogen generated will be almost completely green. An electrolyzer is a system that uses electricity to separate water into hydrogen and oxygen through a process called electrolysis. In its most basic form, an electrolyzer contains a cathode, which has a negative charge, an anode, which has a positive charge, and a membrane. Water electrolysis is the electrochemical reaction that takes place within the cell stacks of the electrolyzer system. Electricity is applied to the anode and cathode across the proton exchange membrane, PEM, and causes the water to split into the two molecules it's made up of, hydrogen and oxygen. Cummins makes both PEM and alkaline electrolyzers. The difference between the two is in the electrolyte. PEM electrolyzers have an ionically conductive solid polymer that initiates the reaction, and alkaline electrolyzers have a liquid electrolyte to initiate the reaction. Both harness power from the same chemical reaction, but with different materials. At Air Liquide's facility, we've installed 4 of the HyLYZER 1000 PEM electrolyzers. These 4 interconnected modular units can be run individually or in unison, and more units can be added to further increase this facility's capacity. The electrolyzer splits water into hydrogen and oxygen, so the first step of electrolysis is water intake. At the Becancour plant, water comes from the city utility through a pump. The water then goes through a demineralization process to remove all inorganic salts by ion exchange. This purifies the water at a similar quality as distillation. Using water at this quality level helps improve the longevity and efficiency of the electrolyzer system. After the water is treated, it's pumped into the electrolyzer cell stack. Let's explore the electricity input. The Cummins HyLYZER at the Air Liquide plant receives electricity from Quebec's electrical grid. Quebec has an incredibly green energy grid. 99.78% of its power comes from renewable energy sources. That means the hydrogen generated has an incredibly low carbon footprint. The voltage is reduced and then connected to the power supply of the electrolyzer, where it's converted to a direct current to initiate the electrolysis process. The 4 interconnected HyLYZER 1000 units have a combined capacity of 20 megawatts of electrical input. The units can operate on a 24/7 basis, generating up to 8.6 metric tons of high-purity hydrogen gas per day, powered by clean hydroelectricity. That's over 3,000 tons per year. 1 single ton of hydrogen can fuel 1,000 fuel cell cars for 100 kilometers each, or 32 fuel cell buses for 350 kilometers each. Compared to a traditional hydrogen production process, this new production unit will prevent the release of nearly 27,000 metric tons of CO2 per year, or the equivalent of the annual emissions of around 10,000 cars. The electrolysis process is quiet, has low vibration, and does not affect nearby equipment. The oxygen that's left over from the chemical reaction can be vented out or captured and used for other purposes, such as industrial processes or even medical supply. And when the hydrogen gas is ready, it is then piped out of the electrolyzer units for liquefaction. When hydrogen gas is cooled, it forms a liquid. Liquefaction processes use a combination of compressors, heat exchangers, expansion engines, and throttle valves to achieve the desired cooling. Storing hydrogen as a liquid can be beneficial. It takes up less space than storing it as a gas at normal temperature and pressure. Once liquefied, hydrogen can be maintained in pressurized and insulated containers and tanks. When the liquid hydrogen is ready for shipment, liquid tanker trucks fill up from the storage tank to distribute the hydrogen to the market. Liquid tanker trucks can carry 3,000 kilograms of hydrogen. That's 10 to 12 times more hydrogen than gaseous tanker trucks. The Air Liquide plant can produce 2 truckloads per day. Cummins is leading the charge in hydrogen power with similar projects, built on decades of experience and related hydrogen generation projects. Cummins has deployed more than 600 electrolyzers in 100 countries globally. Air Liquide and Cummins installed a 1.2 megawatt PEM electrolyzer called HyBalance in 2018 in Denmark. The site supplies clean hydrogen to customers and helps support Denmark's carbon reduction goals. In partnership with Air Liquide, this electrolyzer provided proof of concept and was the predecessor that led to the Becancour project. Expected to be operational in 2021, the 5-megawatt PEM electrolyzer in Douglas County, Washington State, will be the largest and first of its kind used by a public utility in the U.S. The new system allows the utility district to produce commercial hydrogen with hydropower from the Wells Dam on the Columbia River. Announced in May 2021, Cummins is locating one of the world's largest electrolyzer manufacturing plants in Spain. The 22,000 square meter facility will produce electrolyzer systems with an initial production capacity of 500 megawatts per year and is scalable to more than 1 gigawatt per year. This manufacturing facility is expected to open in 2023. Additionally, a 230 megawatt green hydrogen production project is also planned in Spain, which will become the next benchmark for large electrolysis projects globally. As producers in early adoption markets, we use our learnings to improve the enabling technology, bring down costs, improve performance, and ultimately incentivize additional markets to transition. Already a leader in advanced diesel, natural gas, and battery technologies, Cummins is rapidly growing our capabilities to support the blossoming hydrogen economy. We've invested in the entire hydrogen value chain because we believe that developing and growing the hydrogen economy is essential to the future of our planet. As we continue to make green hydrogen more accessible, we're looking to the future with goals for the decarbonization of many industries, including transportation. Cummins is accelerating the hydrogen economy by investing in a unique portfolio of hydrogen technology from electrolyzers to fuel cells, tanks, and powertrains. For more examples of how Cummins is pioneering new firsts in the fuel cell and hydrogen industry, visit cummins.com/hydrogen.